Hi everybody, this is the third video of chapter 1. In geometry, we're going to be talking about measuring and constructing angles. So an angle is going to be a figure that is formed by two rays that have a common endpoint, and that common endpoint is called the vertex. So if we have a common endpoint and we have two rays that are coming off of it, that is going to be an angle. This here and here would be called the interior. And out here would be the, I almost put outside, that should be exterior, right? So when you name an angle, there are several ways you can name an angle. Sometimes they will be labeled with a number on the inside. So this would be angle 1. Sometimes you'll just know a letter that names the vertex. We would call that angle R. Otherwise, if you have 3 points on your angle, let's call that one S and this one T, you can name it by 3 points that are on the angle, in which case your vertex has to be your center one. So regardless of how we name this, R has to be in the middle if I'm going to use all 3 points. So we could call this angle SRT, or we could call it angle TRS. Either way, the R has to be in the center because that tells me that R is the vertex of my angle. Now, if your vertex is also the vertex of another angle, you can't use R to name the angle. You have to use the 3 points to name the angle. Or if that individual angle is named a number, you could use that. So let's practice that. Let's say a surveyor went out and he recorded the angles formed by a transit, point T right here, and 3 distant points, this building, and that building. All right, and we're going to just call those points Q, R, and S. So let's name 3 of the angles. So the first angle I see is this one right here. We cannot name it angle T because point T is the vertex of all of them. So what we can name it as is angle STR, or, not and, or RTS. Once again, T has to be the center. The next angle that I see would be this one right here. This angle we could name QTR, or angle RTQ. Our third angle that I see is the one that goes between these buildings right here. So we could name that angle QTS or angle STQ. Once again, you cannot name them angle T because T is a common vertex between multiple angles. So this is a postulate that's called the protractor postulate, just because it has to do with how you would use a protractor, similar to how you would use a ruler on measuring a line. Let's say you are given a line AB, and a point 0 on line AB. So let's say not 0, but point O. All the rays that could be drawn from O can be put in a 1-to-1 correspondence with real numbers. So let's say we drew a ray out here, and we drew a ray out here, and here, and here, and here. All of these could be put into a 1-to-1 correspondence with real numbers. So the measure of the angle between B and A, this measure right here, is 180. So when we measure them, we're not going to measure them in inches or centimeters. We would measure them in degrees. And there's 180 degrees between one point on a straight line and the other point on a straight line. Now, there are multiple types of angles that can be fit within that protractor postulate. Multiple angles that happen between getting to from B to A. So remember, this is 180 degrees. So an acute angle is going to be greater than 0, but less than 90. So this would be a 90-degree angle. Pretend that's a good drawing. So anything that is in here is going to be acute. It's going to be less than 90 degrees. A right angle measures right at 90. And an obtuse angle measures greater than 90. But it has to be less than 180 degrees, because if it's 180 degrees, we wouldn't say it's an angle any longer. We would say they are opposing or opposite rays, creating a straight line. So a straight angle would be the one that is formed between, that measures 180 degrees. So you can go skinny, you can go 90, you can go obtuse, and you can go straight. Those would be our types of angles. So let's measure and classify some angles. To do this, you would have to use a protractor. So when you're looking at the protractor, let's say you have the image on your in your book and you're wanting to measure them, you're going to find the little dot that is on the protractor and line that up with your center there, in this case 0.0. You'll want your straight line to be measured to line up along, there should be a line right here, and it should go through 0 on this side or 0 on this side. So we're going to find measure of each of the angles. The way you do that, when it's all lined up, let's say we were looking for AOB. What we would do is we would look where our B is lined up right here. In this case, I can see this is an acute angle, so I'm going to use the smaller numbers. So if you're lining up from this side of your line, you're going to use the inside. And if you're lining up from this side, you're going to use the outside. And you should be able to use some common sense to see that you can just look at this angle and know it is not 140 degrees, so it can't possibly be the outer edge of the protractor we're going to use. We're going to use the inner edge, which would be 40 degrees. So using that, I want you to try to see what the measure of angle AOD is. All right, AOD, so we are going from here to there. So our A is lined up at our 0, so we need to follow to our D right here. We are using our inside because we are measuring from that side right here. This is definitely an obtuse angle, so we're going to use on the inside. It is between 160 and 170, exactly in between, so we would say 165 degrees. And then if we were going to classify it, we would say it is obtuse. How about COD? So it's a little trickier because while we have it lined up, our C is not on the bottom line lined up at 0, and our D is not on the bottom line measured up at 0. The way we found the length of a segment on a ruler was you would take the absolute value of the difference between the two. So we're going to do the same thing. So we're going to pick one side or the other to read and go from there. Let's just use the inside because that's what we used for the A. So our D right here was at 165. So I'm going to take 165. And our C is at 105. So I'm just going to subtract those. I'm sorry, I used the outside. It should be the inside. That's not 105. So I'm using the inside. So I did a 165, which means I've got to do on the inside here, which is 75. Sorry about that. All right, so our 165 minus 75 would be 90. So absolute value of that would be 90 degrees. So we would say that COD, was a 90-degree angle. Now our angle addition postulate is quite related to the postulate that we used in the previous chapter, where when you add up the two segments, they add up to the whole thing. It's the same thing. So if you've got this angle and this angle, they're going to add up to this angle. All right? So we're going to use our angle addition postulate to find the measure of DBC. So remember, we could say that ABD plus DBC is equal to ABC. Now we know ABD, which is 37. We don't know DBC, but we know ABC is 84. So to get my angle DBC alone, I'm going to subtract 37 degrees from this side. So the measure of angle DBC should be 47 degrees. You can't always look at a picture and say, oh yeah, that's an acute angle, my numbers should be right, because you're going to be going by the numbers rather than necessarily by the pictures, especially if I'm the one drawing them, since I'm a great artist. So if you look at, this is just about the same thing as having the straight lines. So when something bisects it or it makes it in the middle, remember each of the two that it separates out are going to be equivalent. So just like in a straight line, an angle works the same way. So let's say that this ray right here bisects angle ABC, right? So it's cutting it in half. Bisecting tells us that the two pieces have to be equal. This and this are going to be equal. We would measure, you could tell that from looking at it on a picture because of the tick marks. So remember, in a straight line, if it bisects, we would say those are congruent. The tick marks in this case are going to be single lines, single little curves, and we can see that they are congruent. So given that, ABD, which is this one right here, is going to be congruent to DBC. So those are going to be equal to one another. So in order to find ABD, to find what the actual measure is, we're going to take our 6x plus 3, which is the measure of angle ABD. We're going to put it equal to the measure of angle DBC, which is 8x minus 7. And we're going to solve for x. I'm going to take my 6x over here so that I have an even number x, and not, I'm in a positive number, not a negative number. So I'm going to subtract 6x. I'm going to add 7 to both sides. That'll give me 10 is equal to 2x divided by 2. That'll give me 5 is equal to x. Does that tell me the angle of measure ABD? It does not. I have one more step I need to do. I need to take this 5 and substitute it in place on my ABD to get my number. So 6x plus 3, and then I'm going to replace my x with a 5. So 6 times 5 plus 3, that would give me 30 plus 3. So my angle is 33 degrees. When you come to class, make sure that you're able to measure and classify angles as acute, right, or obtuse, and then be able to use the angle addition postulate and congruent angles to find the measure of unknown angles. Have a good evening.